Welcome back to Meet the Mission, the podcast where we take you behind the scenes at Parsons and meet the people and projects solving the world's toughest infrastructure and national security challenges. In today's episode, we're diving deep, literally, into the world of water treatment and emerging contaminants, from invisible threats like 1,4-dioxane and PFAS to the rising concern around microplastics. We're exploring how Parsons is leading the charge in identifying, treating, and remediating the contaminants of tomorrow. Joining me are two subject matter experts in the forefront of this mission. Dr. Ryan Thomas, Parsons Emerging Contaminants Principal and Chemistry Director, who brings more than 16 years of experience in analytical chemistry, technology advancement, and regulatory collaboration. And Kristi Diller, Parsons PFAS subject matter expert with deep field expertise in site characterization and remediation of complex environmental issues. Get ready for a conversation that blends science, strategy, and solutions, all in the service of protecting our planet's most precious resource, water. Thanks, guys, for joining me, and welcome.
Thanks for having us.
Hello.
Absolutely.
Very excited to be here.
Yay. I appreciate you guys taking the time out of your afternoon to kind of come here and focus on this very important issue. But before we get started, right, on the technical questions, this is my favorite part of our platform, where we kind of get to know you guys a little bit deeper and a little bit better, So I have some icebreaker questions for you. I'm not sure who wants to get started, but my first question is, water is essential to life, but if you could turn any beverage into a clean, sustainable water source, what would it be and why? Thanks.
Yeah, love that question, Candace, and I'll take it first. If I could turn any beverage into a clean, sustainable water source, I would have to choose coffee. I mean, it's certainly my go-to beverage in the mornings.
Absolutely.
Or even early afternoons. Of course, coffee is one of those widely consumed beverages globally, and just production involves a significant amount of water, so that would definitely be the one for me.
Okay. All right. I don't know, because are we saying that we're getting rid of coffee if we're converting it, or are we just saying it's an additive? Because I need my coffee. Like,
Exactly.
I'm with you. Like, I will not survive without coffee. So I don't know. It depends on, am I going to get the same benefits, right, once we convert it from coffee to water? No?
No, probably not. The way I was thinking there is like reducing the overall environmental impact associated with the cultivation and processing. But getting rid of, no, I still need my cups.
Agreed there. All right. Kristi, I'm going to direct this one to you.
All right.
What's the most surprising thing you've discovered in the field, scientifically or geographically?
A couple years ago, I was out at a project site in South Carolina doing some field work to install a remedial system. And we were taking some soil samples, digging pretty deep. We were like 15 feet down in the ground, and I was processing this soil sample. And as I was like handling it, something poked me. And I was like, what was that? And I dug through and I pulled out a shark tooth. Which is crazy because then we ended up finding like many shark teeth in this same lithologic layer about 15 feet below the ground. They've been there forever. They've probably been there millions of years. So,
Right.
So wild to have found that. Very unusual. That's
So were you
the
guys
oddest thing I've encountered.
Were you guys credited with finding that? Was that something that people weren't expecting in that particular, location? And so now you've made some new discovery, or is that oh, yeah.
Yeah, it turns out everybody else already knew that happened. I actually went back and looked at some of the geologic records and found that it's a very fossiliferous layer. So there are all these other fossils and shark pieces. So yeah, it wasn't actually that unusual. To me, it felt unique though.
Absolutely. I agree. To me, that feels super duper unique. So I would tell that story to everyone I met at this point. So, all right. One more for you, Ryan, and then we'll do one more for Kristi, and then we'll move into the stuff that people are really here to be for. So if you could invent one gadget to instantly detect contaminants in the field, what would it look like or do?
Okay. So instantly detect in the field. Well, first, they have to be portable. So handheld device, it'll have to be kind of like a smartphone type of platform. Have a sensor in it that can analyze not only air, water, and particularly soil samples for really a wide range of contaminants. I mean, this could be heavy metals, pesticides, pathogens, and of course, emerging contaminants. Um, I think it'll need to have real-time data and visual alerts just to help with a more user-friendly interface and kind of display the levels of potential contamination there. That would be my kind of go-to if I could just have the magic device, right? That would be the one.
Okay. All right. Have you ever thought about building something that, or getting Parsons, right, obviously, to create something that could be marketed for that use and like you guys could use it? Because that would be a really good innovation to bring to Parsons. That would be awesome.
Yeah, through our internal research and development programs, we've been evaluating sensors for some contaminants. And so, wow, that might be why it's on my mind, right? Because we've been talking about it, been thinking about it, and just kind of put it all into one neat little package would be amazing, I think.
Yeah, that's really cool. And, one of the things that and this is a little early in our segment, but one of the things that I love about Parsons is our ability to leverage, other areas of technology for the benefit and the advancement of, other areas, right? So it's like, if you have an idea, I feel like a lot of times we can go out there and pitch it as an IRAD, and it, moves the industry, not just the bottom line for Parsons. So, Parsons plug right there, guys.
There it is.
All right. Last one, Kristi. What's one environmental myth you wish more people understood the truth about?
Thanks. This one's easy. I have a gripe about using the term forever chemicals to talk about PFAS. So we're going to talk a lot more about PFAS, but that's per polyfluoroalkyl substances. That's what it stands for. And it's one of the emerging contaminants we'll talk more about. They're man-made chemicals. And yes, they are highly stable because of this really strong carbon-fluorine bond they have. But that doesn't mean they're completely indestructible and that they'd remain unchanged indefinitely. So like, the media, if there's a story about PFAS, they always use the term forever chemicals in it. But advances in science and technology are leading to the development of methods that can completely break down PFAS and destroy it to non-toxic end products. One of our Parsons colleagues, Natalia O'Connor, she published a journal paper about one of the PFAS destruction technologies she's helped develop. And she used the term forever no more in her title. And I just love that because it's like, I think calling them forever chemicals really oversimplifies the issue. And it's important to recognize that science is moving it forward to where we actually can remediate and completely destroy them.
Why do you think it's, and I don't know how long the journey has been since people have started identifying ways, right? But why do you think it's not more widely known or more commonly known? Is it just because the advances are so new in the industry, or I don't know? What do you think?
Yeah, it definitely is new. Like we are finally getting to the point where we understand PFAS a little bit better. We understand the complete destruction. Previously, and Ryan will probably talk more about this later, but analytical methods weren't there to let us know if it was completely destroyed or not. But now those advances have been made. We understand how to quantify that better. And yeah, this is the current science problem we are working on, is how to destroy PFAS.
Absolutely. Okay. All right, so let us go ahead and dig in, without any further ado. So let's start with the basics. For our audience who may be new to this, what are emerging contaminants and why is it so critical to address them now? And whoever wants to take it first, Ryan or Kristi, but I'd like for both of you guys to give us your thoughts.
Thanks.
I can kind of kick it off here. Emerging contaminants essentially are chemicals or even materials that have been detected in the environment but not yet regulated or commonly monitored. And so these can be pharmaceuticals, personal care products, even microplastics, and then PFAS, like we've been mentioning, in addition to 1,4 and dioxane. And so they're often found in water sources, soil, and air, and their overall presence can potentially pose risk to human health and ecosystems. And so they have different properties in terms of being stable, recalcitrant, really not susceptible to degradation, but certainly putting an input of energy in can support overall destruction and mineralization of some of these compounds. But those are my first thoughts. I don't know about you, Kristi. What are you thinking?
Thanks.
Yeah, I'd guess I'd add that tack on to Candace's questions about like why is it so critical to address them now? Really there's usually a regulatory gap early in the emergence of these new chemicals. It takes some time for the regulatory agencies to understand the science surrounding them and then determine what thresholds would be protective of human health and the environment for these chemicals. So, like at the beginning, there really aren't guidelines or regulations, but by addressing them now, we're preventing potential human health and environmental crises. We're developing effective management strategies to reduce their presence in the environment. And then just the kind of overall ensuring a safer and more sustainable future.
Absolutely. So I'm going to pull on that thread a little bit. And Kristi, you kind of mentioned this, and Ryan, you can take this one. From an analytical chemistry and academic perspective, how has the science behind detecting these contaminants evolved in recent years?
Yeah, no, I like that question, particularly because really academia has been leading the charge on a lot of the innovation and just understanding the basic science behind some of these technologies that are going to get prioritized for commercialization. And so the science behind just detecting emerging contaminants has evolved significantly. And just looking at some key developments such as enhanced sensitivity and precision. I mean, if you look at analytical techniques such as high resolution mass spectrometry and even liquid chromatography, tandem mass spectrometry, I mean, that just sensitivity and precision is there to support detection at trace level for many of these contaminants, all the way down to the part per trillion or nanograms per liter for PFAS in this case. If you just think about, different analyses in terms of looking at a broad spectrum. I mean, if we look at non-target analysis, meaning that looking for, having become more prevalent, letting researchers detect that wide range without having prior knowledge of their presence is really the key there. And so that helps to get at the unknown unknowns a bit more. It's quite useful in discovering new or even unexpected compounds in the sample. Another one that comes to mind would have to be on the sample preparation piece. I mean, just understanding new methods, solid phase extraction and using automated sample processing. It helps to really streamline the overall process when you're looking at thousands of chemicals at once and try to understand, what the implications of detection are there. Those are kind of the first ones that come to mind for me.
Thanks. And then I just to follow up on that, because coming from this background, I don't have as much I had to do a lot of research, right, to understand kind of the things that you guys are facing. I come from a cyber and defense background, but there's some similarities, right, where you're processing data points, right, and you're looking for ways to be able to make correlations across that data. And so that's how I think of it in terms of, tooling and analytics, right? Because there's a vast amount of information and you kind of need some automation to kind of direct you in terms of where you can start to draw conclusions. Is that a way to look at it from those people who may not have as much experience?
Yeah,
in a certain...
I think that's a great point. And that's something that is another thing that has evolved is this data analysis and computational tools. I mean, just integrating sophisticated data analysis, software, computational tools has enhanced just our ability to interpret the complex data sets and again, identify the unknown compounds and, importantly, understand their behavior in the environment, really the overall fate and transport and how that might be migrating to a sensitive receptor like a drinking water or water source. And so, that's exactly right, Candace.
Absolutely. Okay. Makes a lot of sense to me.
I'll jump in there too and say,
okay.
For example, of how complex PFAS is. So there are like 12,000 different PFAS compounds. So
Amazing.
like the ability to measure all 12,000 of those like doesn't exist yet, like in a targeted quantitative way. So we have to focus in on just a few key ones, and then understanding the dynamics of how they transform between each other and what changes, like in fate and transport. So like when they're in the environment, or if you're trying to remediate them, how they, transform and degrade. It's so complex. So there's a lot of analytical information necessary, and then like the data processing side is huge, and analysis of that data constantly evolving.
Yeah, and that's what I was going to say, and I'm sure it's evolving at a very rapid rate,
Yeah,
and so staying abreast of those trends is a job in
yep,
itself, probably. So all
definitely.
right. So let's kind of, again, pulling that thread, because I think we're kind of going into that internal initiatives and IRAD projects. So what internal initiatives or IRAD projects at Parsons are currently undertaking or trying to tackle emerging contaminants like PFAS and 1,4-dioxane or microplastics?
Yeah, so Parsons is actively engaged in several internal initiatives and those internal research and development projects, or IRADs, that you mentioned. So we're researching ways to like detect, measure, and then ultimately remediate and completely destroy emerging contaminants, like especially PFAS and 1,4-dioxane. We have a couple exciting new patents that we've recently got. One is for a process called hot ISCO, and this is a catalyzed chemical oxidation for the destruction of PFAS, so degradation and destruction of PFAS. It's unique because it has potential to be applied in situ, so that means in the ground surface. So a lot of PFAS technologies that currently exist require the contaminated water to be above ground. So you have to extract that and like treat it above ground. So looking for a way to treat PFAS while it's in the ground. So like just that native in the groundwater is just a much more cost-effective and sustainable way to treat PFAS. So Parsons is really excited about pushing that forward. We have another one that's about catalyzed UV system, also patented, and that's for PFAS destruction. And that one's going to be a flow-through cell reactor. So that's exciting new developments, continually pushing that one forward. Any other specific ones you want to mention, Ryan?
I think you hit the main ones, particularly for our subject here of emerging contaminants. The only thing I'll mention is that, we utilize our internal research and development laboratory located in Syracuse, New York, really to perform treatability studies using this site-specific media. So I'm talking soil, water, sediment, anything that's actually impacted real-world samples on a small scale to, mimic site conditions and optimize overall solutions using the technologies that Kristi just mentioned. And so, that's a huge advantage because we can manipulate the conditions in a variety of treatment scenarios prior to going full scale or even to the pilot scale, just to kind of focus in what's going to be the better technology for that particular site. So certainly important to have that research lab that can support not only the internal projects, but also our client projects as well.
I think.
So out of curiosity, right, because we're mentioning, these efforts that are either underway or have already kind of been produced. What, in your opinion, how has innovation changed, since over the last like 5 to 10 years in these areas? What are the ways that innovation has shaped how we are sampling, analyzing, and treating emerging contaminants compared to, 5 or 10 years ago?
Yeah, and that's a good one. I can kick that one off. I know that kind of like we were talking about in the intro here, on the improved sensitivity for new sampling methods and just detection. I mean, many years ago, there was really a threshold or a limit on how low, you can get to detection for PFAS. And so now we have these much lower concentrations, part per trillion and even part per quadrillion in some cases, which is really crucial for identifying, trace levels of emerging contaminants. I think it's also, a sampling technique thing that we can think about that has really evolved, particularly for passive sampling and just allowing for continuous monitoring over time, just providing more of a comprehensive picture of that contaminant and its overall presence. On the treatment technology side, I mean, we've been talking about the catalyzed oxidation and, even reduction technologies. But, there has been a lot of work in this space, particularly on filtration methods. And so just thinking about clays and zeolites and just modified granular activated carbons that are more absorptive and more selective towards contaminants. And one thing I like to always mention here is that it would be great if you can go out and just find, that the contaminant by itself without anything else, but there's other things that's there. We call that co-contaminants. And so those co-contaminants are going to impact your ability to treat it with oxidative reductive technology or even the filtration technology. So being more selective certainly helps. And, that has, evolved last 5 years. I mean, we see a lot of companies that are putting a lot of energy and time and efforts to just get ahead of those issues.
I think
absolutely. Okay, so I wanted to focus a little bit of a spotlight on, we're really focusing on Parsons projects and research and the kind of the things that are happening. So Kristi, I wanted to talk to you about Parsons was selected for a major PFAS investigation and remedy development project at the airport. So can you walk me through that? What makes this site unique and how are we approaching the challenge differently?
I love talking about this project. So this is in Tucson. This is at the Tucson International Airport. Been spending a lot of time there over the last couple years. Such a beautiful place.
Yeah.
This airport is really complex because there are many folks there, both the airport itself and then surrounding military bases and industrial uses, where they all were mandated or opted to use AFFF. So that stands for aqueous film forming foam. This is a firefighting foam that the FAA mandated the airport use to protect, human lives because it puts fires out very, very quickly. But it has PFAS in it, turns out. And PFAS, we now know, is quite toxic. So where they were forced to test and train with this foam, they released it to the environment, and now it's impacted soil, groundwater. And here in Tucson, it's been impacting drinking water. That drinking water is now being treated by the city, but there's a large program to fully investigate all of those different sources. So very complex since this contaminant was released in like many different locations in this area around the airport. So, we're approaching this challenge with a comprehensive strategy for site investigation initially. So we're using some advanced techniques for site characterization and data analysis, like using high resolution site characterization, getting a vertical aquifer profile to understand how that contamination changes with depth and making sure we understand how it extends laterally. And then moving forward, then we'll be looking at ways to remediate that and treat that and contain it there on the airport facilities to prevent it making its way to the drinking water wells. So it's going to be a big project going on for many years into the future.
So I was actually just about to ask that, what is the timeline on a project or, investigation to remediation? What does that look like, as you guys are planning and strategizing?
It can take many years to decade, really. The investigation portion is usually iterative. You have to take a phased approach. You might start by sampling where the contamination was released, and then you analyze that data, and then you have to step out to where you found that it keeps going. So you might have many mobilization to do field work for site characterization, and then you have to write a big report about that, and then you move into the treatability studies, perhaps, like Ryan mentioned, our treatability lab in Syracuse. So maybe we'll do some laboratories type testing to understand what remedial technologies might work, and then maybe you'll go to like a pilot scale test in the field before you would go to a full scale remedy. So it's a long process.
Yeah, absolutely. And then, this is just the curious Candace asking questions, right? From your perspective, if someone's looking to be a part of, some major undertaking like this, and what do we look for as like roles or responsibilities in this area? Like, do you need a slew of chemists or biologists, or like, what does that look like if someone was like, I think this might be a cool career path?
Yeah, I mean, it is a very multidisciplinary team. We have project managers who are helping guide the work, they usually have a scientific background, so they understand what's going on. And then you'd have your geologist, your hydrogeologist, engineers, field staff, so just like even field technicians who love being outside all day and want to be the ones out there collecting the samples. Chemists like Ryan supporting all the laboratory work and data validation, data validators, folks in the office who are just processing data, helping with databases, helping make maps, so GIS or CAD drawings. And then Ryan, did I miss anyone really key?
So sorry, I put you guys on the spot.
No, I think that's perfect. I mean, it's always an opportunity for folks to get involved. And, the one thing I mentioned there is that it's great for entry-level people who are, coming out of undergrad or even graduate school and looking to just get more hands-on experience in the field. And so I think the reality is that you can go multiple pathways. I mean, if you like the technical, you can stay technical. If you like the R&D, you can get into the research and development piece of a project. I mean, there's a lot of different avenues there.
Yeah, like some multidisciplinary. Right? Yeah.
I thought of somebody else who's actually really quite key to these projects, and that would be a community involvement coordinator or communicator. Like it's especially a project like this where the community really cares about it since their drinking water is impacted. So I know Parsons frequently prioritizes that stakeholder and community engagement and might have a person who's solely dedicated just to that task, just to communicating with the public.
Yeah, absolutely. And that was something that I didn't even think about because it's just, a lot of us want to know how we can get more involved and how we can be more impactful, right? And so that is a amazing, role that someone could take on that has like real world impacts.
Exactly. Yep. Very important to be able to translate our like jargony scientific talk into what the average person understands, and like it can help them understand what's happening at the site.
Yeah. Awesome. All right, we're going to take a little bit of a switch. Kristi, let's talk about 1,4-dioxane. What is it and why is it categorized as an emerging contaminant, and how is it released into the environment?
All right, so 1,4-dioxane, again, it's another synthetic organic compound that was used as a solvent or a stabilizer for chlorinated solvents. Used in a lot of industrial applications. So, solvents have really good ability to clean and degrease. So used in industrial applications, at dry cleaners, at military sites. So it was released kind of accidentally back before we really understood how toxic it was. We might just have a sump at the bottom of a building and we would put our wastewater down there. So many different ways it can get to the environment, but basically accidental releases.
Okay.
And so it's categorized as an emerging contaminant because we really didn't know that much about it for a while. We've understood chlorinated solvents that it's frequently paired with, so it was used as a stabilizer for chlorinated solvents. Chlorinated solvents we've been remediating for, 50 or more years right now. But 1,4-dioxane wasn't well understood. There weren't analytical tools yet able to detect down to the small concentrations necessary to understand the toxicity. That really kind of happened in the mid 2000s. By 2012, the federal government had established a drinking water health advisory for it. So that's why it's emerging, because we've really only been thinking about it from the remediation perspective for like the last 15 years at most.
Can someone talk to me about how difficult it is to remove 1,4-dioxane once it's been detected?
Happy to take that one too, because this is what I spend a lot of my time doing. It's complicated because its chemical properties and behavior in the environment are so different than those other chemicals I was talking about. So chlorinated solvents are well understood. We know how to remediate them. But unfortunately, 1,4-dioxane behaves differently, and you need like totally different remediation techniques to clean up 1,4-dioxane. So there are some fully demonstrated technologies for 1,4-dioxane that can effectively remediate it in the environment. Things like soil excavation, thermal treatment, phytoremediation using trees to take up the contamination from the groundwater. But then there's many other ones that are emerging technologies. And which some of these are really fun. I love these. We've been focusing in on in situ bioremediation. So that means there are microbes, so these little bugs that live natively in the ground that can actually degrade and like kind of consume 1,4-dioxane and turn it into innocuous products. We have a site in South Carolina, the one actually where I found the shark tooth. And at that site, we know these microbes exist there in the ground, but they just don't have the right aquifer conditions that they need in order to be able to consume 1,4-dioxane. So the project we're doing, like basically they need more oxygen in order to want to consume the 1,4-dioxane. So we are going to, we've installed a system, we're going to turn it on later this month, where we're going to inject air into the groundwater, and that's going to give the microbes the oxygen they need and want to be able to accelerate their consumption of 1,4-dioxane. So that's a really novel, innovative project that I'm looking forward to seeing how it works.
Yeah, that's exciting. And you know, it's interesting to kind of pick you guys' brains and hear like the different things that you guys are trying in these arenas that are going to be groundbreaking or kind of revolutionary and will shape, you know, how we are doing these assessments and remediations, right? So I think that's really exciting.
Yeah, and Parsons has been on the forefront of contaminant remediation for a long time. You know, chlorinated solvents, I mentioned, you know, 40 years ago, Parsons was helping to develop some of the technologies that are now very standard. We use them all the time, all over the world. And Parsons was helping develop those at the time. So I love that we find a new problem and we keep trying to create solutions for it.
Yeah, absolutely. So speaking of that, there was a recent acquisition of TRS Group. So how do you feel that enhanced Parsons, you know, already very strong foothold in PFAS remediation capabilities, or overall service offerings, right? Because you guys have been telling about a lot of different things that we are doing in this space, but how is TRS Group going to augment that and add to that?
We're really, really excited to have TRS on board. They are expanding our offerings because they're renowned for their expertise in thermal remediation technologies. So they've been treating all kinds of contaminants with thermal technologies. That means they basically heat up the ground surface and destroy those contaminants. But they are now applying that technology for PFAS as well. So this is groundbreaking. They just have been doing some research with the federal government, with the DoD, to demonstrate this technology and have proven it successful. So now it's about to go full scale and be offered to a wider audience. So that's a new groundbreaking technology. And then they also have this other product called perfluoride. And so this is a process that they provide to basically remove PFAS from water, and it's really effective at cleaning out AFFF and removing PFAS from firefighting systems. So as I mentioned, that old foam AFFF was toxic and had PFAS in it. So now there's a new foam called fluorine-free foam, or F3, that folks are moving to. So as a way to get away from using the toxic chemicals. But in order to put F3 into your fire trucks, your fire suppression systems in your building, you need to clean out all the old AFFF to make sure you fully removed PFAS. And TRS's perfluoride system does that.
Yeah. Awesome. The only thing I'll add there is that, you know, we just recently won a project in collaboration with TRS to do just that for an airport. And so we're certainly looking forward to, you know, working in that space and making sure not just, you know, those trucks are cleaned out, but also the tanks, because we don't want residual. Because what we've been seeing and through TRS's experience is that if you have residual AFFF there and add, you know, the fluorine-free foam to it, then you start to get this kind of globular formation that can actually, you know, diminish the efficiency of that overall system, and so causing you to have to re-clean it. And so certainly that's the added bonus that TRS brings to the Parsons team.
I think,
So just out of curiosity, like the process to, we've identified that we're going to clean out those systems, right? So that we can use the new solution. But is that does that take a lot of time? Is that a weeks process to clean those systems, or is that something that we're doing faster these days?
Yeah, I would say it's faster just because of the optimization piece of making sure that you're doing the rinsing, but also understanding that if you have residual there, you can get, detection of that through faster turnaround time so that you can continue on with that process. And so
Right.
I think with more opportunities, it just continues to be optimized here.
Okay. Very interesting. And one of the things that was mentioned, with new federal administration, what changes do we think we're expecting around contaminant thresholds or regulatory standards for water treatment? What do you guys think in that arena?
Yeah, I could kick that
You can
one
start,
off.
Brian.
I mean, I think, as we've seen with other changes in other federal administrations, environmental policies and regulations are typically influenced just based on the administration's priorities and their approach to environmental issues. And so some of that can be on the regulatory adjustments, meaning just the shifts in the focus of setting, those thresholds for PFAS, emerging contaminants, and even other water quality values or what have you. And so understanding that piece, but also just the funding and the research. So sometimes we can see these allocations are kind of moved around just to balance the overall priorities. But specifically for something like a PFAS, I know that recently we've seen the EPA have notified that they'll retain the maximum contaminant levels for two of the many PFAS, or PFOA and PFOS, but are looking to reconsider some of the others in terms of the overall determinations and extend some compliance deadlines out into, I think, 2031. And so that's one of the things that we have certainly seen in the past 5, 6 months here. Another one is that, just the time frame shift for some of the reporting. And so PFAS reporting, there's a rule on the Toxic Substances Control Act. We call it TSCA. And we've seen that it's kind of been pushed out by almost a year. And so I think it was October 2023 where, the regulation was going to require manufacturers of PFAS to really report certain data to the EPA. And they had a window. So originally it was July of actually this year, 2025, all the way through the end of October of 2026. But now all of that has been shifted a bit. And so it's still, I would say, dynamic and evolving, but those are just some of the early ones that, we've been noting. I don't know, Kristi, if you've been seeing some other ones too.
Well, the one other thing I wanted to mention is I would expect with this new administration that they're going to give the states a lot more flexibility to have control on these topics. So even if, the EPA has indicated they might roll back some of the PFAS regulations, I'm sure there will be many states that still, retain the existing regulations they have and or implement new ones. So I can see this government giving the states more control over regulation of emerging contaminants.
That definitely makes sense. So, and this is piggybacking kind of on a topic that we discussed earlier. You did mention like community advocates. How do you think if we're pushing the control back towards the states for making decisions and providing the regulatory standards, and you're working with a company kind of like Parsons, how do you guys think we should approach building trust, right, with those community stakeholders when executing complex remediation projects that have visible public health implications? What are ideas that we kind of have around that?
I think,
I can speak to that some. We advocate for really clear and transparent communication with the community. We want to be honest. We want to share information when it makes sense to share it, and engage those stakeholders, whether it's community members or adjacent landowners, whoever it may be, and the regulatory agencies as well. Engage them early and throughout the entire project life cycle. So for example, at the Tucson project, we have monthly calls with our regulators There are quarterly meetings with the broader stakeholder group where the other parties that also are contributors to the PFAS in the area get together and communicate. Then there's also quarterly community meetings where we're conveying new information to the community, allowing them to provide their feedback. And then I think it's really important to be responsive to that feedback. You know, like if you get some input back from your community that they care about something or other, like you should prioritize that. So yeah, we really try to focus in on building strong trusting relationships with all those community members.
Yeah, I love that. It sounds like communication is central to,
Yeah,
like you said, communication, but also transparency within those communications is going to be central to building that trust and that relationship.
absolutely.
Awesome. All right, so we're rounding out to kind of the end of our time together, and I just kind of want to look forward, right? So looking ahead, and Ryan, I'm going to ask you to start here, and Kristi, you can piggyback if there's anything that you wanted to mention, but what excites you most about the future of water treatment and contaminant remediation?
Yeah, no, I think we've been talking about it a lot. Really passionate about the technological advancements and just the innovations there. I mean, just these cutting edge technologies such as the filtration systems and nanotechnology, bioremediation, phytoremediation that even Kristi was mentioning, this certainly offers promising solutions for really more efficient and effective contaminant removal via PFAS, emerging contaminants, but even some of the legacy contaminants where we're finding new technologies that can be applied there for more effective remediation. Another piece, and I think you had kind of touched on it too, Candace, was just this complex data-driven approach, really understanding, how data analytics and artificial intelligence and water treatment allows for just, overall better prediction and even monitoring to help, optimize that treatment. So that's really where I think the excitement is going for me.
I think
That definitely sounds exciting.
I think.
All right, Kristi, if you could wave a magic wand and fast track one advancement in this space, what would it be and why?
Oh, I wish I had this magic wand because I would be like, boom. We now have an in situ groundwater technology for PFAS. Like for me, it's that easily applicable groundwater remedy to destroy PFAS wall in the subsurface. Like we are waiting for that day to come, and I wish it would come sooner. We're working hard on it, though.
Yes, we are, and I believe that day will come. So I think I love the passion and kind of the diligence that you guys both bring to the table with figuring out innovative and creative ways to address these issues and to remediate these emerging contaminants. And I think it's one of those things where if you really want to be involved and have impact, this is a great space to kind of contribute to and get involved in because it's the essence of impact and community involvement and community engagement and just making the world a better place, as cliche as that might sound. Well, I want to thank you guys for your time again, and I'm going to address the audience here at this point. This is the end of our episode, but one of the things that I wanted to kind of hear from Kristi and Ryan, I normally, share my thoughts and feelings about Parsons and why this is a great place to work. But I think their lens and their unique eye, especially with the groundbreaking work that they're doing, I kind of wanted to turn that over to them. And the final question, right? For you, Ryan and Kristi, why Parsons? Why is this a good place to get involved in this arena? And why would Parsons be a place where we tell people, if you're interested, go to parsons.com/water-solutions to look at careers here and look at the projects and capabilities. But for you, why Parsons, Kristi? I'll start with you first and then Ryan. Why Parsons?
All right. For me, it's the diversity of work I get to do. Like the number of opportunities I've had to work on such a fascinating array of projects. Like no one day is exactly the same. I just really love the research and development we're doing and the ability to try to apply those innovative technologies in the field. They don't always work, but even in that process, you're learning something. So just really appreciate Parsons' focus on innovation.
Yeah, absolutely. I love that. Okay, Ryan, what about you? Why
For
Parsons?
me, I've been here for about 3 years, coming from another international consulting firm. And, it really was the collaboration and technological advances that kind of brought me through the door. I mean, I saw, the Parsons Fellows and really that group that, has this strength to do internal work and actually bring it to market through the entire company, but also understanding that we can work with folks on the outside, academic researchers. We can have agreements set with, folks who are doing that development of treatment technologies that we were just talking about. I mean, that really drives me to want to come to work, stay here, and also bring others with me. So
Awesome. I love that. All right, so outro to everybody. Be sure to follow, rate, and subscribe to Meet the Mission so you never miss an inside look at how Parsons is building a safer, smarter, and more sustainable world. And until next time, keep imagining next. Have a good afternoon.